We are on the page 19, section 4.1. Okay, we are going to talk about graphing a line. So we said 3 things we are learning in this class, right? First thing was in your exam 1, solving linear equations. Second thing we are going to learn is to graph linear equations. So let's take a look at some graphs first. And look at your page 21. Let's see some graphs and how we interpret them and how we will look at them, right? So for the first one, on your page 21, a graph look like this, right? So a lot of time you saw on the news or different places, and you will have this type of things, comparison for different cases, right? Or on this one, on our page 21, it looks like this, right? So what kind of graphs we will call them? It looks like bars, so we call them what? Bar graph. Then how we are going to read them and what kind of meanings they provide. So like this one here say country, right? Here says internet users and in millions. So by looking this graph, and it says, okay, approximate the number of internet users in Japan. So you will see the categories. Right here is Japan. So you will look at that and see how many users, roughly. So you see, okay, so it's about what? 85 millions, right? Then for next one, it says find the sum of number of internet users in the US and Japan and China. How you will do. So you look at the US, that's the US, right? Then you match with the number, the indications there, then which will be around how many? Say, okay, almost 200. So you say, okay, 195 millions. Then how about next one, Japan? We know it's about 85 millions. For China, it's right here, right? It's right on the mark, so you can tell it will be what? China, let me see, 120. So total will be what? You add them up, right? About, oops, if I can add, right? 400 millions. That's how you read the bar graph. And next one, and we have another graph. It looks like this. What kind of graph you will call that? Not the bars, so we call this one what? Line graphs. Okay, and the information given here says what? Pulse rate is heartbeats per second. Heartbeats per second, right? Then here says the time when people start to smoke. So here is 0. Here is what? Before the 0 time. So it says, what is the pulse rate 20 minutes after lighting a cigarette? So you look at what? The time, 20 minutes is here. You match with the number here. Then the indication is right there. So it's about what? it's about 70, right? You look at the left-hand side, it's about 70 heartbeats per second. Per minute? Oh, per minute. Per minute, not per second. That's way too fast. Right? The next one, he asks, name the 5 minutes intervals where the pulse rate increases. What do you think? So increases means what? Going up, right? Going up, like here. So here would be what? Between -5 to 0 minutes. What does that mean? It means even people start to smoke, they start to feel excited. The heart start to pump, right? The next one, between here, 0 to 5 minutes, when they just start to smoke, then their heartbeats increase, right? Next one, it's right here. So you look at the time frames. So that will be what? Then they cool down a little bit, then after that, 25 minutes to 30 minutes, and they start to increase the heartbeats again. That's how the line graph is telling you, right? He also says, is the pulse rate ever less than 60 beats per second? So how you will decide? So you look at the left-hand side, and here is what? 60, right? So what is that? That would be right before when? It would be right before -5 minutes. So 5 minutes before the person smoked, their heartbeats are what? Less than 60 beats per second. Got idea? So what are we doing? We are looking at different graphs. We are going to do what? Graphing a line, right? So before that, we have to see what kind of graphs they are possibly we might encounter those. So then next one, we are going to talk about actually doing it, okay, to graph lines. Okay, so before we graph lines, we talk about how things work out and what kind of references we will use for graphing lines, okay? So we use this kind of system, and we call it what? Rectangular coordinate system. What does that mean? So what do you think a rectangular means? It means what? Rectangular shape, things like this, right? Coordinate means what? They coordinate with each other. Means, you know, left and right and up and down, they coordinate with each other. Just like your what? Computer screens, right? So when we want to graph lines, what do we need to do? We need to know how far we go to the right, how far we have to go up to make the point there, make a point there, right? Make all the points there so you can see the line, right? So you need to know how far you can go left and right, or how far you can go up and down, right? So we call this what? Rectangular shape. So we use this as a reference, okay? when we graph a line, like on your computer screen, right? So then before we do that, let's review something we talked about before. It's those one, you have to have what? Left and right, up and down. So you have to what? 2 references to use so you can graph the lines, right? Before we learn this, if I have x equals -1, how many references we use? Just one number, one letter, right? Then when we graph it, so it would be what? Just one reference thing. So you say, okay, usually we put a 0 in the middle, then -1 would be on the left-hand side. That would be your -1, right? That would be your x. That's what we mean. Then if we do what? X less than or equals to 5, it means what? I only use one reference. So I will have what? One reference line. Then this is my 5. My x is what? Less than that. So I will have many numbers, right? Can be 4, 3, negative something, all the way up there to the left. So then we do include the 5. That means what? It means you have equal sign here, means inclusive is 5. So we have to include the 5, then we use bracket. Right? We did this before for using one reference. So in general, that's what we said. Okay, so if it's one variable, we need what? One axis, right? So one reference line. If I have 3x minus 4y equals 12, how many variables we have there? 2. That means when we graph it, we need a what? 2 axes to graph it for the reference. Then x will go what? Left and right. Like here, x will go left and right, and y will go up and down. Okay? So that's how we use the references. So that's how we look at it. Since we use this one, we call this one what? Coordinate system, right? They have to coordinate with each other. It's not just random, right? Between x and y's. So this will be your x-axis. This is your y-axis, right? So for x-axis, what do you think of what's in the middle? You will put a 0 there, right? And so you go right will be positive or negative. Usually we do what? Positive on the right. On the left, that would be what? Negative. Right? And as for y, what do you think? Going up would be what? Positive. Right? Going down would be what? Negative. That's how we identify them. Right? So, for 2 axes, we split the screen, rectangular screen, to how many parts? 1, 2, 3, 4. Then we'll count it this way. Okay, so we counted counterclockwise. So this is coordinate 1, 2, 3, 4. Then we have 4 quarters. So each one will call them what? Quadrant. Okay? So this is the first quadrant, second, third, and fourth. And each point in these 4 areas, so let's take a look. So if I have -4, -4 and 2. Well, what do you think? Where is it? So it's follow what? The orders. So follow alphabetical orders. So X, Y, Z, so on, right? So we call them what? Coordinate system. So they coordinate with each other between X and Y's. So -4, what do you think? You do X, that means X. So X, you go where? Left and right. So you start from in the center, right? So in the center, what do you think the position would be? That would be X is 0, Y is 0, right? You're not moving. Then -4, you go to left, 1, 2, 3, 4. Then Y jump up and down right here. So which quadrant it is in? You would say second quadrant, right? So this one is X coordinate, this is Y coordinate. And if we ask you, where is 5, 0? What do you think? It's in here? Any quadrant? Any quarter? Not really. It's where? 1, 2, 3, 4, 5. It's right here. It's not in any quadrant. It is what? On x-axis. Right? Then if we ask you, where is 0, -4? What do you think? How would you answer it? That would be not there. Would be right here, 0, then come down what? 4. It's right here. Right? That would be on where? Y-axis. Right? So first we identify them, how we will recognize them, where to put the points, right? And with rectangular shape. With what? 2 references, X and Y axis. Okay? Another thing we need to remind you is this. We just did earlier when we do the inequalities like this, right? Say if X is in between -1 and 2, how should we show it? If it's just one variable, right? One reference, it means what? It's here, -1 and 2, right? So we say, how do we show? It's just not one number, so we use what? Graph to show it, right? Or we can use what? Interval notation. We use this interval notation to show it, right? However, if in the 2 variables world, what happened? That would be this one, right? -1 and 2. So you do -1 and 2. It's right here. Which quadrant it is in? It's in what? In the second quadrant, right? So what we wanted to mention is this way. So depend on your references. One is what? One reference, another one is 2 references. So for -1, 2, when we write it this way, it can mean what? Possibly 2 things, right? So you need to beware. This is that usually for math, one symbol means one thing, okay? But this probably is the only one behave little bit different. So it's like this. So this one can mean what? One variable world will be what? An interval notation, right? This is a one variable world. If it's in two variables world, it means what? We'll call this one ordered pair. Any point in the two-dimensional world, we call them what? X and Y, they follow the orders, right? We'll call them what? Ordered pairs. Okay? But in general, you can tell what we are talking about, which one we are talking about. We will let you know. Okay? Just be aware of it. So, for math, usually one symbol means one thing. Okay? This is a kind of exception here. All right. Then we have to decide. So first we had identified, what kind of graphs we are looking at, a bar graph or a line graph, right? Now we identified the symbols, we call them what? Ordered pairs to plot the points in a what? Rectangular coordinate system, right? So that's how we graph. If you do programming, computer programming, do the graphing design, you will use those XY coordinates to put, if you put a robot here, then where you put your dots, X and Y's, to show the positions, right? In next one, we are going to decide whether or not, right? If I have a line here, if I have a line like this, okay, then how do I know, okay, my point is on the line, right? So, we did early on, we say solving linear equations, right? So we say if I have equations like this, only one variable, what's the answer for x? You know x is 7, right? If x is the solution for the equation, when you plug in, it should work for the equation, right? This is one variable. If I have what? Two variables, what will happen? So if I have x plus y equals 10, okay? What do you think my xy can be? I only have one answer or many answers. What do you think? Right? So you think it's ordered pairs, so I have x and y's. Then what kind of xy's will work? Will 1 and 9 work? 1 plus 9, yes. 2 and 8 work? Yes. 3 and 7 work? Right? So how many you have? Can I use, say 20 and negative 10? Would that work? 20 plus negative 10, still 10, right? So how many answers you have? Tons of them. Many, right? So how do you decide whether or not the points or the pairs given will work for your equation, right? How do you decide? So all you have to do is what? You plug back in and check, right? So first we decide how many, what kind of points will work for the equation before we graph them, okay? So if we have this 3x minus y equals 12, we ask you, oh, this point, will this point work? Okay, or will this point work for that equation? What do you think? By plugging in, right? So you do 0, x is 0, so you follow the orders, x and y, z, right? So x is 0, so you do 3, 0 minus y, 12. Would that be 12? 0 minus 12, negative 12. So it will not work, right? How about this one? 1 and negative 9. So you plug in 3 times 1 minus 9 minus y. Y is negative 9, right? Is that 12? We ask. So 3 plus 9 is 12. So this one is one of the solutions for the equation. Because for x, y, two variables in one equation, it can, many answers. For the next one, if x equals 7, if we write it this way, but now we are in the two variables world we are talking about now, okay? So, y is missing. When y is missing, it means what? Y is free to be anyone. Okay, so it means what? Y means y can be what? 1, 2, 3, or any numbers, because y is not there. Okay, so we ask you if it's a 7, negative 2, it's a part of this equation, right? If negative 2, 7 is part of this equation, or 7, 5 is part of this equation, right? What do you think? 7? Yeah, x is 7, so it's good. Here, x is what? Negative 2, not a 7. Oops, no good. How about this one? 7. Good. So those are part of this equation, right? Look at the next one on your page 20. If we give you an equation like this, two variables in one equation, and both power just 1, not the higher powers. Okay? Then if we give you this A, B, C, we give you x is 0, and here we give you y is 3, we give you x is negative 4. What are we asking you? This one is what? When x is 0, what do you think the y will work for this equation? That's what it's saying. So what do? You plug in x for 0, so you have 0 plus 2y equals 8, right? Then what's your y? Divided by 2, so y is 4, right? So you need to know how to solve linear equations before you can find the points on the line, okay? If you still have trouble solving linear equations, that means what? You are in trouble, right? You need better catch up. So this one is saying what? When y is 3, what's your x? So you plug in y 3 to the y, so you will have x plus what? 2, 3 is 8, right? Then that's 6, so you minus 6, so x is what? 2. That's what it is saying, right? Then for this one, what are we saying? It's saying, oh, x is negative 4. So x is negative 4, then plus 2y equals 8. What's your y, right? You solve your linear equation, then 2y equals 12. Y is what? 6. Is that right? Okay. Another way later on we are going to show is using this thing. So we call it t-table or t-chart with x and y. Okay? So I will have x is 0, y is 3, x is negative 4. Then we expect you to find the coordinate point. Means what? All of the pairs will satisfy this equation, right? So if x is 0, y has to be 4. If y is 3, your x has to be 2. If x is negative 4, your y has to be what? 6. That's what we are saying. Okay, all those symbols. And we use what? T-chart, T-table. Okay, so we identify those, order the pairs for us to do the line. So for the linear equation, then we find out what kind of things we call a linear equation later. So first, we identify those pairs, order the pairs, which will work for the line, for the equation first. So if we give you this, right? An equation, and which has what? Fractions. So you do the same. So if I give you negative 3, 0, 0 here, what do you need to do? You need to find the order the pairs which will work for this equation, right? Even for an equation with what? Fractions. So let's see. What do we have here? So that one is what? X is negative 3. So find your y. So y is what? 1/3 times negative 3 minus 1. Then you put a 1 underneath. Cross cancel. So what do we have? Negative 1 minus negative 1 is what? Negative 2. So you put your negative 2 here, right? And for this one, x is what? 0. So you plug in y is 1/3 times 0 minus 1. Anything times 0 is 0, and minus 1 is what? Negative 1, right? And this one, y is 0. So what do? So you say 0 equals what? 1/3 x minus 1, right? Then how do you find your x? Solve for x. Get x by itself, right? So add 1, so 1 is 1/3 x. Then how do you find your x? Get x by itself. How do you get rid of 1/3? You multiply it by its reciprocal, right? So that will be what? 3/1. So that's 3. So you times 3 on each side, so you can get rid of 1/3, right? So x is what? 3. So when y is 0, x is 3, right? So this is for section 4.1. What we have been learning is using the rectangular shape, right? Coordinate system to identify the x and y's, right? Your 4 quadrants and x and y's. And use those ordered pairs to show what kind of points will satisfy your equations, right? So that will be your section 4.1.